Welcome to the wild cosmic stage where science struts like a superstar and the universe gets its very own movie script. Imagine, guys, long ago, before your favorite Talaivar, before villains, songs, or even slow motion entries, everything existed in a single ultra hot, super dense point. Then came the biggest bang, the Big Bang, the greatest hero entry ever. From action packed galaxy types, every family drama you can imagine, to the blockbuster life story of stars, you'll witness the ultimate science masala in this lecture. So keep your snacks ready and, of course, a pen ready to take notes and a sense of humor switched on because in this universe everyone has a starring role. And remember to subscribe so you don't miss out on the sequels. So, what's bigger than superstar Rajinikanth's fan base? The universe itself. Scientists believe, okay, that everything, space, time, matter, and energy popped into existence in the biggest opening scene ever. That is the Big Bang which happened. Think of it like the start of a blockbuster movie with no trailer, just pure explosive action. Before this Big Bang theory, people had their own theories on how the sun and planets formed. But now we know we were all born from that cosmic masala. The Big Bang was not just a Big Bang. It was like Thanos snapping his fingers, except instead of disappearing, everything appeared. Around 13 point billion years ago, the universe kicked off as tiny, hot, dense singularity. No, not the robot Rajini from India, but the original cosmic superstar. Everything expanded, cooled down, and like a slow motion hero entrance, atoms, stars, and galaxies enter this scene. The only thing missing here is the background music. How do we know this is not just a big like the ending of certain movies? We have some solid evidence to prove that evidence of supporting the Big Bang theory. Doppler shift, red shift and blue shift. Imagine every galaxy is an auto rickshaw, honking as it drives away. The farther it goes, the redder the sound gets. So Hubble spotted this first. Okay, Hubble spotted this first. So he is basically the detective in our sci-fi movie, revealing that the universe is expanding. So this can be very well seen in our Earth in day-to-day basis as well. So when the sunlight is far away, our sky looks red. But when the sunlight comes closer, the sunlight changes into blue. So that is the Doppler shift, red shift and blue shift for your reference. Next one is the cosmic micro background. This is the leftover sambar from the universe wedding feast. It's a faint thermal radiation detected from all directions in space. And it was discovered by Penzias and Wilson in 1965. This confirms the universe younger, hotter days, which is after the Big Bang. Next one is gravitational waves. Not the waves we do at the cricket stadium, but invisible space-time ripples from the cosmic mass dance. Like think young Rajini shaking the universe during inflation. if scientists can spot these ancient waves. It will be like finding the secret dance master behind the Big Bang theory or Big Bang. See, quantum fluctuations during the inflationary period led to the initial or primordial gravitational waves. Now let's look into the types of galaxies. Hubble classification scheme, a cosmic version of Willen's meeting. See, galaxies are vast groups of stars, gas, dust, and dark matter which are held together by gravity. Edwin Hubble developed the famous Hubble classification in 1926, which divides the galaxies into following main types. Spiral galaxies, stylish donuts with spiral arms with dramatic flare. See, a flat rotating disk with spiral arms binding outward from the central bulge. The Andromeda galaxy is one such example, or we can even call it Milky Way galaxy. Yeah, Milky Way is a galaxy. Milky Way galaxy, the galaxy which we are in, is a spiral galaxy. Next one is elliptical galaxies, round to the oval but still boring to look at, but powerful, like the strong and silent villain. Next one is the irregular galaxies. These are the comedy sidekicks, like no shape, lots of drama, and loads of new stars coming or forming. That is, these are the few types of galaxies. Moving on with the Milky Way galaxy, like imagine a city bigger than Chennai, full of stars but no potholes. Our Milky Way galaxy is a grand barred spiral galaxy. It's approximately 100,000 to 120,000 light years in diameter. Galactic bulge, it's a packed center with full of people, we can call it like like full of stars in the middle, with the supermassive black hole, which is Sagittarius A. Next one is galactic disk. This is where the real party is. Young stars, gas and dust. They are just chilling in the Orion arm. Next one is the halo. Old stars, dark matter, the wise uncles and aunties are floating around. This is the galactic halo. So, and our galaxy is estimated to contain about 100 to 400 billion stars. So, Earth location is located in the Orion arm, that is as discussed in the galactic disk, a minor spiral arm of the Milky Way. Distance from the galactic center, that is the center of the galaxy, is somewhere around 27,000 light years. That's a huge. The Earth lies about 20 light years above the galactic plane. Our solar system orbits the galactic center at an average speed of 828,000 kilometers per hour, or you can call it. That is faster than any hero's car chase and does a full lap of every 225 to 250 million years, except there are no traffic signals though. Formation of stars. Nebula. See, stars are born like movie heroes from humble beginning, and here's the plot. Nebula. Huge cloud of hydrogen and helium, a cosmic biryani in the making with heavier elements. Dust cloud. Gas and dust clamp up like gossip in a wedding everywhere. Like they go clamp together everywhere. Next one is dust cloud to globulous. Gas and dust clump up like a gossip in a wedding. Next comes the protostar. Squeezed so tight like it starts to glow in infrared due to an increase in pressure. but still, it's not a superstar yet. Next comes the brown dwarf. See, if a star does not get enough mass, it becomes a failed hero. Neither planet nor star, like a flop debut movie. Following on comes the main sequence star. Achieves core fusion, achieves core fusion and becomes a box office hit, burning hydrogen and shining for billion years together. Moves on with red giant, has runs out of fuel and expands, hogging the cosmic limelight like a veteran coming back for a cameo. Next comes that when star's blockbuster run ends, it sheds its outer layers and leaves behind a white dwarf, a tidy, hot, dense cosmic veteran, roughly the size of Earth, but with more mass than superstar Rajini's fan base. It chills on the cosmic couch, cooling slowly for billion of years, shining for all those who remember the glory of that old days. But the show is not over yet. After countless eons, much longer than waiting for a sequel, this white dwarf will cool so much that it becomes invisible and turns into a black dwarf. The ultimate background extra of the universe. So far, none exist because even the universe is not old enough yet. Imagine waiting for the next superstar movie so long that even your grandkids give up. If the star is massive, box office hit with all the budgets, the end is pure cinematic drama. When all fuel is spent, it goes into supernova, a cosmic explosion so epic that it makes any film climax pale in comparison. The star throws a tantrum, ejecting its layers, lighting up the universe like Diwali in Chennai, which also leads to core collapse of the star. The leftovers. If the core's mass is between 1.3 or 3 solar masses, it squeezes into a neutron star, denser than any villain's dialogue, holding more weight than MGR or Rajini. Debates. If the core is even heavier, it collapses into black hole, the ultimate no access zone. Not even light or gravity is so strong, which makes it most mysterious anti-hero out there. It's the place where even the paparazzi can't get a shot. That's the formation of star. With that, that's a wrap, guys. As the cosmic curtains close, remember this universe is wilder and funnier than any Hollywood climax. Stars burst onto the scene, shine through their prime, and exit in style. Sometimes as wise white dwarfs, sometimes with explosive supernova finale or disappearing into black holes. Every galaxy is a blockbuster, every nebula is a rising hero, and every night sky is a cosmic set waiting for fans. So the next time you glance up, remember the Big Bang's epic origin story, the dramatic journey of stars, and the endless cycles of creation and mystery. Stay curious, keep laughing, and always keep learning. Like the cosmos, like the ultimate movie. And don't forget, the biggest stars in the universe always subscribe. So hit that button now and join our cosmic fan club for more adventures. Thank you.